Okay. Well, good afternoon, good evening to everyone. Thank you for joining this webinar, August webinar on transitioning from oil and gas to geothermal. My name is Jason Assir. I'm the CEO of EnergyGigs. On the call today, we have our new market development executive for New Energies, Jason Fisher. He's going to be leading the discussion today on transitioning from oil and gas to geothermal. We have a little bit of a presentation that we're going to go through first. But if you have any questions, which we hope there will be a lot of questions, please ask your questions in the chat, and we will. We've built this presentation around the idea that it can be you can ask questions and Jason can answer them. And to the extent that I can answer any of them, I will do my best. But that's not my skill set. But anyways, without further ado, I'll turn it over to Jason Fisher, our market development executive for New Energies, including geothermal. So over to you, Jason.
Hi, everyone. Thank you again for attending another one of our lunchtime webinars. I'm Jason Fisher, Market Development Executive for New Energies, which includes geothermal, hydrogen, and carbon capture. And today we'll talk briefly, not too deeply, about transitioning from oil and gas to geothermal, navigating the future of renewable energy solutions. As Jason mentioned, I know it might be confusing with both Jasons, but you understand. As Jason mentioned, feel free to ask questions throughout the talk. You don't have to wait until the end. Any burning questions you have, type it in the chat, and one of our team members will relay that message to us, and we'll answer it accordingly. So what is the current state of the geothermal industry? So for the last 4 or 5 years, there have been a lot of interest in the geothermal space coming from across the globe, from the US, Europe, largely, and from Kenya. And a lot of this is focused on getting geothermal everywhere. And how do we get geothermal everywhere? It's a hottest question on everybody's mind. In order to do that, we have to consider alternative technologies separate from conventional geothermal resources, which requires the presence of water in many cases. So in order to do this, there have been a great emphasis on what is known as an enhanced geothermal system for those who do not have experience in geothermal industry. That is a geothermal system where we have heat, but no fluids inside of it. So then we have to create fractures in order to produce the heat by pumping water into it and extracting that heat. So this interest in this space has been growing significantly, with the US DOE having significant amount of funding opportunities aimed towards solving the problem of getting enhanced geothermal systems everywhere by making it cheaper, more affordable for developers to get it off the ground. The second development that is growing even a little bit slower than enhanced geothermal system is closed-loop geothermal. A closed-loop geothermal is created in a geothermal reservoir that has heat but does not produces the water at all. It is created by injecting a working fluid which absorbs the heat, and then you extract that liquid and you produce the heat at the surface. So there is no water extraction from the subsurface. And this will also allow geothermal to be everywhere across the world. However, managing the technical difficulties and overcoming the financial challenges is a big step we need to move towards for closed-loop geothermal. And the last one is geothermal district heating. Throughout the world, particularly in Europe, heating is one of the highest costs in Europe and requires a significant amount of energy. In order to green the heating space, there has been rapid growth of geothermal district heating. This is used in a geothermal reservoir where we extract hot water and then extract the heat through a heat exchanger and then pumped the spent fluid back into the subsurface. So this one actually uses the groundwater, the hot groundwater, and typically uses old oil and gas infrastructure. So the growth of geothermal district heating in Europe is very significant, as it can help decarbonize the oil and gas industry in Europe, and it also utilizes old oil and gas infrastructure, abandoned oil and gas wells, or unplugged, or existing assets that already exist. So we don't have to go out and build new infrastructure, but we can redevelop it and utilize it for geothermal district heating. So how has the oil and gas industry how is the oil and gas industry embracing and moving towards geothermal? Firstly, they're doing so through investments, a large amount of investments, actually. A lot of the oil and gas majors, including Chevron, Devon Energy, BP, Patterson-UI, and neighbors, to name a few, have invested heavily in many different geothermal startups, which focus on very different aspects of getting geothermal everywhere. For example, neighbors invested in a company called GA Drilling, which is focused on developing something called a plasma drilling, which allows us to drill anywhere in the world deeper and faster. So at the current moment, it typically takes anywhere between, I don't know, 2 to 3 months to drill a geothermal well in conventional setting. But with a plasma drilling bit or plasma-based tools, you could completely cut that time in half. And if you cut the drilling time in half, you reduce your costs significantly, as geothermal drilling can be up to 50 or 60% of the total capex of an entire geothermal project. Another interesting investment is the third one listed here. The name of the company is not listed there, but I'll be happy to tell you it's Ever, which is developing one of the first closed loop systems in the world. And because of that, they've garnered a lot of interest from many different international oil and gas companies across the world, and even private equity firms, and have since carried out their pilot project in Canada, and currently has received more investment to pursue their project in Germany, which the drilling just started, I think, like a week ago on that project. Other key oil and gas companies invested in geothermal is Devon Energy, which invested in Fervo Energy, which is utilizing enhanced geothermal systems by using technology from the shale industry to develop geothermal energy, particularly horizontal drilling and fracking. Alongside investments, many oil and gas companies are pursuing collaborations and partnerships. For example, we have Baker Hughes, which is leading a geothermal consortium known as Wells to Watts. The aim of this consortium is to utilize closed-loop geothermal systems to transform dry, non-productive oil and gas wells, as well as dry, unproductive geothermal wells, to develop geothermal power. The companies involved in this is Greenfire, which is one of the leading companies on single borehole geothermal closed loop, completely different from Ever, which is focused on using multiple boreholes and a multilateral system in the subsurface. And it also includes Valorec, which is one of the key producers of downhole casing in Europe. Another aspect of collaborations and partnerships, and also kind of investment, is oil and gas companies participating in the American-made challenges. Throughout the last few years, the US DOE has sponsored a number of these. One of the most popular ones is known as the Geothermal Manufacturing Prize, which aims to advance geothermal tools in the geothermal industry that can withstand high pressure, high temperature, and the corrosive environment in the geothermal subsurface using additive manufacturing. As you can see here in the image on your left, a number of known oil and gas companies have invested in participating in this prize and has made it all the way to the semifinals. One example, two key examples here in the picture is Baker Hughes and Welltec. I'm sure everybody here knows about Baker Hughes. Is one of the big oil and gas technology company, and so is the Welltec team, and they're based in Denmark. Another aspect of oil and gas shifting into geothermal is product market expansion. So a lot of the oil and gas companies are now hiring geothermal individuals or geothermal people into their team in order to expand their total addressable market from just oil and gas into the geothermal space. A number of companies are doing it, including Baker Hughes, Schlumberger, Expro, in order to expand their current services into the geothermal space. For example, Expro, which is known in Europe for their well flow management systems and their well integrity systems, are now expanding those systems into the geothermal space, and as such, they're looking for a geothermal technical sales manager in order to help them expand into the geothermal space. Scalability, on the other hand, is a bit unique. They have been in the geothermal space for a very long time. They're a consulting firm known as Geothermex, but now they're expanding more of their technology into the geothermal space, and as such, they're hiring geothermal subsurface power plant domain head in order to lead some of the work, and also a domain head for geothermal in the surface facilities, i.e., just the power plants, wellhead technologies, monitoring tools, etc., etc. And for Baker Hughes, for their oil field services, they're expanding into geothermal technology and partnerships. So they're trying to develop technology to solve a lot of the challenges experienced in the geothermal industry and to help geothermal industry get to everywhere. So what skills can we transfer, or can individuals or companies transfer from the oil and gas space into the geothermal space? One big example, which was spoken about recently by Dr. Rita from the University of Houston and her SPE Distinguished Lecture Series, is using skills from the shale boom to power the development of enhanced geothermal systems. If you remember, enhanced geothermal systems are where we create a reservoir or create pathways for fluid flow in a reservoir, i.e. we use some form of fracking, which in geothermal we refer to it as hydro-shearing, to create pathways for the fluid to flow so it can extract the heat, and we can then extract that fluid to generate power or to generate heating, right? Because of the shale boom, several technologies were perfected in the oil and gas industry. This includes horizontal drilling, geological sensing, and high intensity fracturing, which allowed the generation of millions of barrels of oil from resources that were deemed unsuitable. So now these similar technologies that made the shale boom can now make an EGS boom. So we're looking forward to the utilization of many of these technologies and the knowledge gained from the shale boom to transfer directly to the enhanced geothermal systems, which will help us to create fractures and to produce fluid and heat more efficiently. One significant project that is taking place right now is the Utah Forge, which is utilizing several different technologies, and it's open for investors or people who are seeking partnership to go and test out their ideas and their new tools in this space. Another interesting technology that we utilize, or starting to utilize more in the geothermal space, is coil tubing. Coil tubing is typically used in workovers in the oil and gas space. And as such, it has gathered some steam in the geothermal space, largely in the application of workovers, also in the geothermal space, as you can use coilovers without having to completely quench or stop the production from your well. Two main companies at the moment are using coil tubing in the geothermal space, and there's room for growth and there's room for more. And we welcome everybody in the industry so it can grow faster. JRG Energy is one of the key proponents of coil tubing in the geothermal space, using it for scale management in the geothermal industry. GA Drilling, which was recently invested in by several different oil and gas companies, their idea of plasma drilling is to utilize a coil tubing unit in the upper sections of drilling in order to get things going and to reduce the cost. Oh yeah, we'll answer that question shortly. It's a question related to the scalability of geothermal. We'll jump into that shortly. Thank you for the question, Jesse. We'll go through the transferable skills and then I'll jump into that question. So following coil tubing, we have technology. Throughout the years of development of oil and gas industry, they've had years to develop and manufacture several different or thousands of different technologies in order to extract oil and gas efficiently, quickly, safely, and costly. A lot of these technologies can be transferred to the oil and gas, can be transferred to geothermal, especially as we expand from traditional geothermal tied to volcanic areas to enhanced geothermal systems geothermal district heating systems, and closed loop geothermal systems. Some of these technologies include high pressure, high temperature tools. A big challenge in geothermal is the limitation on tools utilized because of the high temperatures achieved in geothermal. However, when you're thinking about geothermal district heating or even some EGS systems, the maximum temperature you might encounter, depends on where you are, is 250 degrees C. Several high pressure, high temperature tools utilized offshore oil and gas can reach these limits. So a lot of these technologies can be transferred into the geothermal space quite easily with minor modifications to handle corrosive fluids that might be flowing inside of a geothermal well. Alongside of that, the oil and gas industry has developed phenomenal monitoring capabilities, particularly as it relates to water reinjection. They monitor seismic activity in order to not trigger, in order to meet their environmental requirements based on the state you're in. So they've developed significant geophysical monitoring tools for hydrofracking and for wastewater reinjection. And those tools can be directly transferred to geothermal at the moment, especially in conventional geothermal, as reinjection is an important part of reservoir management. So those are just two ideas of technology that can be transferred, but there are many more, a lot more. And there are a lot of startups focusing on transferring technologies from oil and gas into the geothermal space. So let's look at an example of a reservoir engineer for modeling focus for geothermal and a reservoir engineer for simulation and modeling for oil and gas. This will help us to see the similarities between the two roles across the industries, and it will also help us to identify gaps that may need to be filled if you're coming from the petroleum industry, right? If you look at these, if we look at the descriptions, we realize that they're extremely similar. They both require knowledge of well testing, which on the oil and gas side is listed as pressure transient testing. In the geothermal side, it's referred to just overall as well testing. And outside of that, you see it's very similar. They require knowledge of conceptual modeling, knowledge of, reservoir analytical performance and prediction, must possess a valid driver's license, very simple and easy skills that anybody interested in geothermal coming from oil and gas can do. The only gap here that's very clear is the experience in the numerical modeling tools that are utilized in geothermal. Because from an oil and gas perspective, we see the simulation technologies utilized there is Eclipse and Intersect, whereas the numerical modeling / simulation technologies utilized in the geothermal space, TUF, Tetrad, CMG, just to name a few. There's also Freak Flow and several other different simulation technologies utilized. So one of the main gaps that needs to be filled if you're a reservoir engineer looking to get into the geothermal reservoir engineering space is to find and learn or go or experience some training to learn these specific simulation modeling tools. So that's one of the key things, the key differences between a reservoir engineer in geothermal and a reservoir engineer in oil and gas. The modeling tools are completely different, and there's in geothermal, there's more consideration for thermodynamics of water and fluid flow, fluid flow is also important in reservoir engineering and oil and gas, but not so much the thermodynamics of fluid flow of water. So how can you fill, if you're coming from the oil and gas industry and you want to go into the geothermal industry, how can you fill your knowledge gaps? One of the biggest drivers towards satisfying your curiosity and getting you on the path to learn or to get into geothermal space is self-study. You have to identify the areas that you are lacking or the areas that you are interested in, and you go out and find resources that can help you to learn and fill that gap. And in order to identify these, you typically identify a person in the industry that is similar to you, have similar roles, had a similar history, and then you reach out to them to develop a relationship so then you can get technical mentorship, right? And that is extremely important in the industry. I've done mentorship to several different individuals looking to move from oil and gas into the geothermal industry, and it has been a pleasure working with them, teaching them all the different aspects of the geothermal industry so they could go on and help the industry to move forward. Outside of that, there are many meetings and conferences globally that you can attend, and at these conferences they always have short courses. Like, for example, coming up in October is the Geothermal Rising Conference, and they have a number of short course offerings which are not extremely expensive, but they're extremely affordable. So I'd always recommend that individuals seek out conferences that have geothermal courses and course offerings. Outside of the GRC, there's the Image. I think Image is happening this week or next week in Houston. There was an AAPG conference. They also have a geothermal course offering there as well. And outside of that, there's in the US, there's a Stanford Geothermal Conference in February, March. They typically have courses as well. Outside of that, you can always find course offerings on International Geothermal Association's website, because they do offer courses from time to time. Iceland GeoSurvey, which is the United Nations Geothermal Training Program, I know they rebranded. They're now the UNUGRO. They typically offer short courses internationally, usually to developing countries. And outside of that, there's a talk of developing certification programs. They're in progress, but a lot of them are not complete. So geothermal certification programs are in process, but they're not fully complete. And if you're more interested in going the degree route, you have an unlimited number of options in order to pursue a geothermal degree, whether it's a master's program or a PhD program. For example, if you're into geothermal engineering, if you're interested in engineering, the blanket term of petroleum engineer, which includes drilling engineer, reservoir engineer, production engineer, Stanford Geothermal School is great for an engineer to attend. Outside of that, you can attend Oklahoma University, you can attend UT Austin. There are many different universities across the world that you can attend where you can get a master's or a PhD in geothermal. And if you're interested in the Europe side, there's TU Delft, which has an amazing geothermal program focused on the development of geothermal district heating facilities in the Europe platform, in the Europe market.
Jason, just a quick question on the degree programs and coursework. I mean, does it break down along the lines of like a type of rock? Like, is it sedimentary programs or volcanic, or are they all look at both? Like, all these programs look at both types of geothermal opportunities?
They vary based on where you are. So in Europe, in Netherlands, the program in Netherlands, a lot of it focused on sedimentary geothermal, which is the focus of the geothermal development in Netherlands. So it all depends on where you are. For example, in the Great Basin Center of Geothermal Energy in Reno, Nevada, they have PhD geothermal programs, and it typically focused on a variety of geothermal aspects. So one of the key aspects of that school right now they receive funding for is what's called blind geothermal systems. So these geothermal systems have no surface manifestation. So there's no hot springs, there's nothing on the surface that tells you that a system is there. So one of the focus of their research is how can we identify blind geothermal systems using all the data from oil and gas and data that we have not thought about before. So it's a play type system which was directly adopted from the oil and gas. So this is another way how oil and gas can help the further development of geothermal. We can apply exploration and reservoir evaluation techniques that has been utilized in oil and gas in the geothermal space. So that's one example. And then if you go back to Stanford, they do reservoir engineering on any kind of geothermal system. So they can do hard rock, or they can do sedimentary geothermal. So they focus on things that are actually being developed and that are being worked on.
So I know Jesse had a question. One of the questions that keep coming up arising with oil and gas professionals, it's scalability. Can you give your thoughts on scalability? I guess even though geothermal has been proven to be scalable.
Right. Yeah, I think geothermal is scalable. And with the recent success of Fervo, there'll be rapid growth of geothermal energy, particularly as it relates to enhanced geothermal systems, as we now see that we can create a geothermal reservoir anywhere in the world. And if you
Hmm.
can create a reservoir anywhere in the world, you can scale it. It's no
Y-
longer restricted.
I guess is part of the question there also kind of an underlying part of it, the notion that there's not like a quick of a payback period for deploying capital versus the traditional oil and gas sort of opportunity. And so
Yes,
as a result, money maybe isn't flowing into those opportunities as much.
right. That's always the challenge. A barrel of water is not the same as a barrel of heat, as a barrel of oil and gas. Because
Yeah.
then I think the main differences between the industries is that one out of 1 barrel of oil and gas, you get fuel, plastics, pharmaceuticals. There's a list of products you get versus from 1 barrel of water, you get heat. And then you
Mhm.
have to become creative in what's your value chain around that heat? Are you going to
Mhm.
produce energy? And then when you produce energy, for example, from 120 degrees Celsius water, when you produce energy, your spent water is about, it could be around 80 degrees. What can you do with that water before you inject it? Can
Mhm.
you then run a geothermal greenhouse? Can
Mhm.
you grow crops for sale? Can you have a geothermal drying facility for wood or for geothermal pasteurization facility to create milk and then sell that product? We have to develop what we call a geothermal cascade. Instead of
Mhm.
using the water for one use, you use it for several different uses before you re-inject. So
Mhm.
that will help to increase the value of geothermal and then even make it more scalable.
Mhm. And I guess also the other side of that is that the timeline of, I mean, you're looking at a much longer timeline than a typical oil and gas well, right? I mean, this is and geysers is how many years old, like versus an oil and gas well, producing oil and gas well, there's some sort of definitive end of life period, right?
Right, yeah. But typically in a geothermal well, one well can last 30 to 50 years once you take care of it.
Hmm.
So you don't need to drill as much wells, but that's also one of the challenges where we don't have all as much empirical data as oil and gas does because they drill um, 1,000 times more wells than we have in their
Hmm.
lifetime. I don't know if geothermal will get to that space, but we will definitely be drilling more wells, especially with the successes we've had and all the new technologies being applied. But a
Yeah.
lot in the US, a large part of the um the extended timeline is a permitting. So if once a permitting issue is handled, then the development of a geothermal project could go from 5 years to 3 years or 2 years.
Hmm.
Could drastically reduce, and especially with technologies focused on EGS or focused on district heating, we won't need to drill to 5,000 meters. We can drill to 1,500 meters and extract heat there. So then with the different types of technologies we have that we can apply in the geothermal space, we reduce our drilling time by not needing to go as deep.
Hmm.
So then that creates an opportunity to shorten the development cycle of the project.
Hmm. So if we have any additional questions, please do ask them. Ask them in the chat. Jason can take them. I I guess question I had was so if you're currently in oil and gas, and like, is it fair to say that if you currently work in the shale space in and around fracking, or you use coiled tubing, those are good pathways to get into, or the easiest pathways to get into geothermal around the EGS.
Yes, they're very simple pathways. And then we have to also remember that most of the breakthroughs in the geothermal space by startups, these startups are all run by ex-oil and gas people.
Mhm.
All people with the knowledge and experience from oil and gas, from the shale boom, from coil tubing experiences, from working in the service industry. They have directly transferred their knowledge into the geothermal space to help it grow. So if
Mhm.
you're looking to get into the space, and you're working in EGS or fracking or have experience working with fracking, a reservoir engineer in fracking, it's easy to consider switching directly into the geothermal space as it develops And as more projects get green light, we'll definitely need more people in that space.
Mhm. Okay. Any additional questions from the audience? Please ask them. Chase, I feel like I might have interrupted you. There might have been a couple more slides, or
No, I think that's the last slide.
okay. Well, I know we do have a current opportunity that we're seeking a business development executive for geothermal in Europe. So if you're interested in that role, please do reach out to Jason Fisher or I, and we'll get you connected to the process of that role. I think that's based out of Aberdeen or Germany or Spain. Is that right?
In Europe, as long as
In
you're
Europe, yeah.
based in Europe.
Yeah. And then I guess one other thing that I was thinking about, and I'd love to hear your thoughts, Jason, is, to what extent when you looked at the two job descriptions, one geothermal, one oil and gas, like is part of the challenge also just like in the whole recruiting process where the recruiters themselves maybe are just looking for keywords and it really they just need to, applicants just need to get beyond the recruiter to the hiring managers, or what's your take on that?
It's difficult to say because while the industry is growing slowly, a lot of companies that want to increase their total addressable market, they need somebody with that geothermal experience initially.
Mm-hmm.
So then once they've had that person on their team, then they can hire people with the willingness to learn and develop the geothermal skills, and then they can be trained. But if you want to immediately take advantage of some opportunities that may be directly in front of you at the moment, you then need somebody with the geothermal experience. And then while that person is on your team, the company itself can then embark on upskilling its own workers, have them paying for or having a private course taught to people throughout the industry focused on the area of the geothermal that they want to see developed. So then it becomes it becomes an issue for the company. Do we want to learn more about geothermal by paying a specialist to come in and teach our people, to provide them with the tools so that they can go out and expand our business into the market? Or are we going to try to find somebody to hire on the team, help to develop our market, and then hire somebody to teach everybody else, or have that person that you just hired as the lead SME for your company, and then have them help to grow your business by teaching the people in your company about the geothermal space? So there are different strategies on how to do it, but it's which strategy is best for what company.
Mm-hmm.
I don't think it's necessarily the recruiters don't know, but it's what's the best strategy for that company. Do they have the time and the willingness to wait until these persons are trained, or can they hire somebody with the experience already and then go straight into market while also giving them the responsibility of training up the rest of their team?
Makes sense. Okay. Well, awesome. I think with that, I know we're a little bit over time. Thank you. I want to thank Jason Fisher for the presentation. What we're going to do, everyone, is we're going to put together a list of resources on where you can find more information to train up and learn more about geothermal and skill up so that you can make the transition if you're in oil and gas and wanting to get into geothermal. We'll send that out to all the attendees, and at some point we'll actually embed that into our platform on EnergyGigs. But with that, though, we really like to thank you for your time. Thank you, Jason, for a great presentation. If you have any questions about geothermal, please reach out to Jason directly or reach out to us if you need any help on finding talent or landing your next opportunity. Wish everyone a great rest of your afternoon. Thank you.
All right, thank you guys. Have a great day.